Welcome to this edition of India Means Innovation, where we discuss the technologically complex innovations coming out of India. Today, we have with us Saurabh Chandra, CEO and founder of Ati Motors. Ati is India's leading robotics company. It has hundreds of clients globally, including 15 of Fortune 500 companies. Welcome, Saurabh.
Thank you so much, Aditya. Thanks for having me here.
Saurabh, you have come up with a humanoid robot, one of the first in India. Tell me what's so special and complex about humanoid robots?
So we've always had this imagination that robots will be as close to humans, which has been very elusive. It's not easy. A lot of the things that we have imagined computers and generally machines can do, we have been surprised as human beings. Computers have learned to play chess before they have learned to pick up a small toy, right? So a 4-year-old can outperform a machine, but Gary Kasparov can lose out to a machine, right? So we always thought we are very special about our intellectual capabilities, but our dexterous and manipulative capabilities are very, very good. Okay. We underestimated how difficult they are. So I think that's the primary challenge which has been very difficult about human. Some things we take for granted is like walking. We think walking is very easy. It is absolutely not easy. It's very difficult. We have had millions of years of evolution, which allow us to walk on two legs, right? Not on four. Walking on two legs is not easy, right? So I think those were really foundational, difficult things in humanoids. Walking and the manipulation part. You think of it from a humanoid's perspective. Where does the battery go? Battery would go in a torso. When you pick up stuff, you become top heavy. So just balancing yourself and making sure you don't fall down. And now it's a big piece of metal. If it falls down on a person's leg, you're going to break his leg. The other part is simply going in an unknown or I would say known but very diverse environment and doing manipulation tasks. That is also very difficult. Third part obviously is the AI itself that is required to make this work because compared to traditional robots which are already popular, which do one task very well and repeatedly, right? So you will have a robot which is doing picking a particular piece of thing, say thousands of times a day. And but it just does that one task all the time, right? So there's a lot of time taken to tune it, program it. But now in a humanoid, the expectation is that you can do a variety of tasks. The robot automatically figures it out, and you need these very large models which have this kind of capability in terms of learning this diversity. So these are the challenges around humanoids generally.
How have you overcome the first problem that you talked about? The placement of the battery. I mean, if you place it in the torso, the center of gravity really goes up and it makes it unstable.
So Ati's approach to humanoids has been a bit different from the traditional, I would say, human. So we are trying to make an industrial humanoid. Our strength as Ati has been with industrial, very large blue chip industrial customers, as you mentioned. In that environment, right? I mean, we have this prior. There's a very good example I like, which is an airplane is not a bird, right? So we take inspirations from birds and made aeroplanes, but none of the aeroplanes flap wings. There are different kinds. I mean, if you have a really large transport aircraft like C-130, it's very different from a Boeing 747, which is very different from an F-16. Right? And none of them are similar to a bird. So our engineering view is that we have to get inspired from human beings, but not try to mimic them accurately. In industrial settings, wheels outperform legs. So we don't want legs, right? So we have a wheeled base, and then we are able to put a battery in the wheeled base, which makes us bottom heavy, right? So it exactly does two things which are very good: more energy efficient. Wheels are more energy efficient than legs. First of all, you can become bottom heavy, and you are faster, right? So what's not to like about it?
So you have resisted creating a robot in your own image.
Absolutely. We're not trying to play God. We are trying to play an engineer.
Right. Your humanoid robots are capable of working indoors as well as outdoors. And that's something very innovative. You don't have humanoid robots in the industrial space that are capable of both.
The outdoor capability primarily comes to us from our navigation technology, which is around 3D LiDAR based navigation, right? Which we were quite a pioneer of doing it. Industrial robots always had either 2D LiDAR mixed with odometry, which is counting your wheel rotations, etc. We took inspiration from self-driving cars and created navigation with 3D point clouds. And we are able to reuse that same navigation in even the humanoid that we have made.
You talked about AI in the beginning. You're talking about LIDARs now. So, what are the technologies that go into making these robots? And tell us about the brain of the robot.
So generally, any autonomous system has to answer three questions. Okay. Uh, you have to first say, where are you? You should know what's around you. And then what's your next step? You ask these three questions in a loop and you will achieve your goal, right? All of these questions then translate into certain technology areas. So where are you is the localization question. If you don't know where you are, how would you know what do you do next, right? So it's an important part. Localization is a very important part, and it can be pretty complex because there are a lot of environments. So if you're outdoor, you could leverage a GPS system, for example, that your cars do. But GPS systems don't work indoors and very close to buildings. Like even in Manhattan, GPS doesn't work very well because they're tall buildings, for example.
Right.
There, right? So that's one part of technologies. Then the perception system, which is what's around you. So you should know what's around you. Is it safe? In a humanoid robot, not only do you need to navigate, but you need to also manipulate stuff. So you need to see around you, recognize objects, recognize their pose, where they are, and then do whatever operation. It may be picking, it may be picking and keeping it somewhere, right? So you have to do these operations after that. The last step is basically your next step, which is often your control layer, as we say, or path planning or trajectory planning, where you are trying to figure out, you're drawing your movement and also doing it. So that's typically control systems. And in modern, many of the robots, you use reinforcement learning based systems. In case of humanoid, you need to see the environment and recognize which task am I supposed to do now? How am I supposed to pick this up? And this is typically being done by the modern AI systems. These are the different challenges that you have to overcome.
Saurabh, you compete globally with Chinese robots. How do you beat them?
A lot of people ask us, right? I mean, and I think a lot of people give up too soon. They say, okay, the Chinese are so good at this, so what's the point, right? Let's do something else. And I think that's a pretty defeatist attitude. I think the Chinese robotic ecosystem has very genuine advantages. So first, we should acknowledge them. I mean, just the manufacturing advantages in China are huge. The energy costs are very less compared to anywhere else in the world. Steel costs, rare earth metals, right? So raw material cost is very cheap. Logistics is cheaper than many of the other countries in the world. Capital is cheaper. Government subsidies are strong, right? So they have a lot of structural advantages which you are up against. But I think, especially in places like robots where these are sophisticated machines. So if you're doing very low end stuff, there is not so much room, right? I mean, you're making a nail or a fastener. I mean, it's difficult, in my opinion. But when you do a sophisticated machine, I think you have many more degrees of freedom of competition, right? You can innovate in many different dimensions. Like the robotic arm in our humanoid is made of carbon fiber. Now, carbon fiber arms are not so different. I mean, as material cost is frankly almost the same, whether in China or India. At the end of the day, you have to out-engineer them, look at your strengths and not just your weaknesses and cry about it. So what are the strengths we have in India? I think we have a great two-wheeler, three-wheeler supply chain already that we can leverage, which is pretty unique to India.
For the batteries.
For the batteries, for even for metalwork, for controllers, right? I mean, all kinds of subsystems which are very similar to robotic subsystems, by the way. That is something we can leverage. Motors also, right? So that's one thing. But you can't drop in. So robotic requirements are slightly different. Now you have to work with the vendors, you have to engineer so that you can take advantage of the supply chain. It doesn't come for free. So largely, right, the other part I think we are able to do in India is very end-to-end multidisciplinary engineering. So India has all the skills, the multiple skills I mentioned. Great thing is that we have access to all of them in India, and you can put together a multidisciplinary team which can solve problems across the thing.
And this entire tech stack of the robot has been conceptualized, designed, architected here in India by your team.
Absolutely. All done in Bangalore. We don't even use some of the traditional open source stuff that robotics companies use because we felt it was not optimal and it reduced our ability to respond to customer needs and evolve, right? So we have done the full stack, all the stack that I mentioned, localization, perception, control, navigation, the AI layer, everything is done, and the mechanical engineering, electronics engineering, so hardware, software, and the application side, fleet management system, monitoring system, the full soup to nut is done here in Bangalore.
Thank you so much. This is a great example of India means innovation. Thank you.
Thank you so much.